have a PowerPoint? Yes, I did.
Oh, okay.
And I think that we had just finished off with the rules for zeros, and we were about to deal with calculations.
Yeah, we just finished rule for zeros. You're right. After the examples of rules for zeros.
Okay, so you did not help me out. Did you write the rules for multiplication and division, addition and subtraction?
That's in the book.
Okay, so I'm hoping the goal of me having you do the outline in the book was so that you have a little bit of a premonition of what we're going to cover in class today. But can you do me a favor? Can you just jot down these 5 rules that we're going to have immediately? And so, yeah, so these are how do we handle significant figures when we're multiplying and dividing. Now, it may not make all that much sense. Hey, be still. Can you do me a favor next to multiplication division? Can you write in quotations a code word that we're going to use for all this? I want you to write the word least and put parentheses, because least is the word that's going to help us figure out how we solve these. Yes, ma'am.
Least or
Least, like as in the least of these. So jot these down really fast. And then I'm going to shift over to the board here to explain stuff. So the two of you that are way, way back there, I'd invite you to come to the front unless you feel like you're okay back there.
I want to call like I have owl eyes.
So really good seeing in the night, but terrible seeing during the day.
I thought they saw good.
I don't know. I feel like they're weaker during the day.
No, wasn't it a hawk singer a couple of times?
It's not zoo. Actually.
Yes.
So I lived in Argentina, and I was so excited the first time I went to the zoo because I love going to the zoos. And the government had like robbed the country of like virtually all the money, and so we went to the zoo, and like there were all these empty cages. But I do remember they had cows, and I thought to myself, this is the first time I've seen a cow in the zoo. And not only that, they had multiple flavors of cow.
Flavors?
I guess that is appropriate since you do
Chocolate, vanilla, strawberry.
clearly
Right.
all of them. All right, you guys have this written down?
No.
This feels like the wrong answer.
Dead.
Well, that's my own cute way of reminding myself of stuff.
The number of
I'm going to do examples of this, so hopefully it'll make a little more sense.
what is it after
Step 2.
you said you're an owl.
And then round is the number of days.
Oh, well done. Did she just? Wow, that's solid.
What is line of death?
You'll learn right now. She did. She rebounded off of you. She said, "I thought you were an owl,"
No, I was
and I'm like, "That is solid. That's very solid." All right, I've grown tired. So what I want you to write down is I want you to write down this example, and I'm going to show you how we do multiplication and division with this example. So jot it down, and I'm going to do this on the board simultaneously. It's going to be 721 times 12. And I will acknowledge right now that we're going to be in a world, and that question is not the way it's or the way it's written on the board and in your notes is not the greatest, because you see how there's no units, and I've always said the number of units doesn't mean anything. But for right now, I just want to focus on the numbers themselves. So here's how we do both multiplication and division. And sidebar on these, you're always going to want to deal with units first, then exponents, and then what I'm doing right now. So these are the really basic problems, but we're going to work our way up to a little more challenging. So in this particular case, the rule that I had you guys write at the top, or the code word for multiplying and dividing, was least. So the game we're going to play is this. Which of these two numbers has the least number of significant figures? Yeah, so doesn't this have 3 and doesn't this have 2? Now, I didn't write down the number. I think it's 8652 was the answer, right? 8652. So what that means is this answer can only have 2 significant figures. So what we do is we always count from the left, and we count over the number of significant figures we're allowed to have. So we're going to go 1, 2, and we're going to draw our line of death to units, or death to digits right there. That means that everything to this side can't stand. Can't live there anymore, okay? Now, The other thing you need to be aware of here is this. See this line of death right here? This 5 gets to make a last request. Picture, if you would, like in every dramatic movie where someone's like clinging off the edge of a cliff and you're holding their hand and then you're wearing a glove and it starts to slip and then I was like, no, right? So picture this as the 5 next to the 6, and as it like loses its grip and starts to fall, it gets to make one of 2 requests. 1, round up, or 2, stay the same. So if the number is 5 or greater, it is round up. So that means that this is going to become 7. Now, here's the problem, and I don't feel like you need to be a mathematician to grasp this, but 87 is not the same value as 8,652. So we're forced to use placeholders. And remember what we use for placeholders? Zeros. So if I put 2 zeros right here, don't I still only have 2 significant figures in my answer? Now you got to be incredibly careful, because if I'm like, I shall dot this, and I put a dot right here, didn't I just make these 2 zeros significant? And that's lying in this particular problem. Now, let me tell you something about placeholders, and we understand the principle of placeholders, so let's talk this through briefly. So y'all know, y'all been to a movie theater before? I also have been to one. See what I'm doing right now? I feel like I've earned some currency with you, doing similar activities as you do. I am connecting left and right. How about you, Owl Boy?
I've been in a movie theater multiple times.
So you're connecting with me right now. Yeah, okay. You weren't talking with someone else. No. Who would that be? See what I did? Laser gun fingers. All right. So I don't know if you've ever done this when there's a movie that's really popular and you go with your whole gang of friends and you go posse. Your posse from my decade. And you go in there and you find like you're like the first in line, and you find like the dead center, the primo seats in the theater. You have the speakers in the right distance. You don't feel dizzy by being too close or whatever. And then as soon as you go there, there's usually like one sucker that's left to guard all of the seats while the rest just go off to get candy or whatever. And if you're ever that person, that is a stressful job, right? Because you're in the best seats in the house. People want to sit there. So what do? You take off like a jacket here, and you put like a purse there and a sock on the one over there, and then you're like this across the things. And here's this incredible social contract that we have with people that come by, because they ask this question. When they come up to you and they look at the seat, what do they say? Is this seat, is someone sitting here, right? Is someone sitting here? There's a shoe. Like clearly there's not a human being sitting there, right? Isn't there a placeholder marking the human that will be there? We don't know whether it's a tallie or a shorty, or an ugly or a handsomey, fatty or skinny. We have no idea about that person, right? Because the placeholder just marks the place where a person was and or will be. You see the analogy I'm making right now?
Yeah.
These right here are placeholders. We have no idea what the numbers are, what they were, what they're going to be. They just mark our spots. Now, I am a huge unfan, I don't think that's really a word, of putting placeholder zeros. I much prefer, you know how we have the ability to shift decimals and make scientific notation?
Yeah.
I much prefer to go 1, 2, 3 and slide this over and call this 8.7 times 10 to the third. See how now I have the 2 significant figures and I didn't have to bother putting in placeholder zeros? Now, I will say this. As long as the decimal is to the left of the line of death, you do not have to use scientific notation. But if the decimal is ever to the right, you must use scientific notation. Because if not, you're going to make zeros that are...
Can you use scientific?
You absolutely can. So let's try this one right here. Let's try one more. Let's try 34.5. Again, unitless, so we know how terrible that is. 34.5 times 3.1. And if you could do me a favor whilst I'm doing this, can you guys pull out a calculator if you have them? And we're going to play the game called Bring Your Calculator. It's not really. In Canada, huge hit, that game. I don't know what it's like here. But yeah, have your calculator every class period. So I've done this for you, and I've written the answer when I multiply these two numbers together. Now, since we are multiplying and or dividing, mustn't we, in our final answer, take the least number of significant figures that we're supposed to have?
Yes.
So in this, doesn't this have 3 significant figures?
Yes.
And once again, doesn't this have 2 significant figures? So if I'm doing this, I'm going to have to draw my line of death right here. Agree?
Mhm.
But here's the problem. Isn't the decimal right there? So the 6, doesn't it tell this 0 to round up? So you're going to have 1, 1, right? But isn't there a decimal place right here? So if I put a 0, what does that make that? A significant number. And we can't have that there because that is not a significant number. And you can't just be like, the decimal's not there. The decimal exists, right? So what we do instead is we're going to shift this problem over to 2 places to the left, right? We're going to shift the decimal place over. And if we shift the decimal place over, doesn't it become 1.0695? Lefty what?
Largy.
That took a long
I was
time.
thinking like
Lefty largy, wouldn't that be times 10 to the second? And then when we wrote this out, wouldn't this become 1.1 times 10 to the second? And this is the only way you can write that with 2 significant figures. Does that kind of make sense?
Not really.
Very nice.
Okay, well, we'll try the ones. Try the ones. Maybe a general rule is this. If you're ever in a position where you have to add zeros to reach the line of death, then make it in do scientific notation. It'll make your problem easier. The decimal is originally right here, and we went 1, 2 places to the left. Now, I don't know if you ever had this happen before, where sometimes a teacher will give you like 2 or 3 really pretty simplistic problems, and then you go home and there's a problem the size of a building waiting there for you. You're like, what the heck just happened there?
Yeah.
So I'm going to try and do the opposite. I'm going to try and give you the building size problem right now. And if you can work through this, then you'll certainly be able to handle the more simplistic ones. Yes, ma'am. I'm in the right. Okay. So I'm going to try one that is kind of mixes all the types of problems together. Okay. So let's do this. Here's the problem. And I'm going to include units, exponents, and the actual math itself. I'm enjoying you doing that right now, but I feel like I might not enjoy it in a little bit. Fair enough. All right, so here's the number we're going to work with. We're going to go 5, 4, 3, 2.123, because I'm not very creative, times 10 to the 4th, and we're going to multiply that by 3.2 times 10 to the 5th, and the unit we're going to use is cows. So we're going to have cows and cows to the 3rd. Your cattle.
Is that?
Because you're what you eat.
Wait, what is it? What is the
Ooh, steak boy.
What is the question?
So we are doing a multiplication with this work right here. Now, let me point out something
What
to you
is
here.
cows and cows and
Hold
third?
on, hold on, hold on. So I've deliberately chosen a unit that we probably aren't going to use very much in chemistry, the cow, right? Because the reason I've chosen this unit is because we sometimes fixate on the units and we don't understand what we're actually doing. So I'm taking a very silly unit, the cow. I like to vary with all kinds of barnyard animals as my units, because whenever we're dealing with units, we do exactly the same thing as we do with exponents. Yes?
Since it's cows, figures the
No. I know you're talking about exact numbers, so pretend that that doesn't exist. Pretend you get a portion of a cow. That's a really good callback on that one, though. All right. So one of the things that I want you to remember always is that in any mathematical problem, what you would typically do to the exponent is what you're going to do to the unit. So in this case, are we doing a multiplication problem? So what would we typically do to our exponents? Add them, right? So wouldn't we do the same thing to our units? Now, this is cows subtracting cows to the 3rd. But you do realize, hopefully, that there's a 1 right here, right?
Multiply, subtracting?
The problem is multiplying.
Okay.
And whenever we're multiplying either exponents or units, we add them together.
Yeah, I know.
Okay?
Okay.
So in this case, we're going to end up with cows to the fourth, and we're going to end up with times 10 to the ninth.
Yeah.
And someone have a calculator out, and can you quickly punch that in? 5432.123 times 3.2.
1,738.
1,000.
17,282.8.
Say one more time, Taylor.
17,382.8.
No numbers past that?
No, sir.
Okay. So this is our number. So haven't we taken care of our units, the illustrious cow, and haven't we taken care of our exponents? And by the way, this is the only time now that I want you to pull out your calculator. Like up to this point, you are dealing with it in your head. Now, once we have the calculator, we punch these numbers in and we get this. Now, isn't the rule for multiplying and or dividing, isn't it to do the least number of significant figures? So don't I have many? And don't I have just 2 right here?
Yes.
And by the way, the least number is not always going to be 2. I just happen to do that. So aren't we allowed to have only 2 significant figures? So I'm going to go 1, 2, and draw my line of death here, which means all these numbers don't count. But I want to point out something to you here. 2 things. 1, don't we already have an exponent?
Yes.
And 2, isn't the decimal on the right-hand side of our line of death?
Yes.
Which means that if we don't shift the decimal, won't we have to start putting placeholder zeros in, and that's going to end up in a mess. So whenever we see a exponent already in the problem, and or the decimal is to the left of the actual line of death, we're always going to make it good form.
Right?
Right? Oh,
If the decimal is to the right.
okay.
Sorry, my bad. I didn't speak. So what I'm going to do is before I do anything else, I'm going to shift this decimal 1, 2, 3, 4 places to the left. So wouldn't that be 1.73825? And didn't I move it over 4 places to the left? Isn't that lefty largy? What's my new exponent going to be?
13.
Times 10 to the 13, cows to the fourth. The units for cows do not change. But now we don't have to worry about like trailing zeros or placeholders or anything. Can we just look at this 3 and see what it says to the 7? What does it say? Nothing, right? So doesn't it become 1.7 times 10 to the 13th cows the fourth? This is our final answer. Yes, ma'am.
So in the book, it said when you were doing like a series of calculations, not to do the significant figures thing until the end.
True.
What if there was both division and like adding or subtracting in it? So which way would you do it, by the decimals or?
So if you have different functions, then I do it step by step. But let's say I'm doing multiplication 15 times in a row. I'm going to wait till the very end and go, oh, the least number was this. Whenever you're mix and matching, I would encourage you to do them simultaneously. By the way, the book read, was it pretty straightforward?
Yeah.
You feel like it was like, you have some of the stuff already? Okay, now watch this. Let's just pretend I changed this and now I have this. Division. Same exact number, same exact everything, except now I have division. What's our order of operation, order of function? What do we deal with first? Units, right? So aren't I going to subtract cows to the third from cows to the 1? Which is going to leave us with the delightful cows to the -2. Again, not one of the more common units that we use. 1 1,000, 2 1,000. You got it? Is that a no? Got it? Do you think that perhaps it's you sitting in the back of the room when there's open chairs at the front is making it hard for you? Gotcha. All right. Oh, that's right. You don't have the ability to just erase one single thing on your paper. Gotcha. So that's pretty straightforward. Now, aren't we dividing 10 to the 4th and 10 to the 5th, but aren't we subtracting the 2 of them?
Yes.
What do we get?
Negative
We
1.
get 10 to the -1. And again, I know that a lot of us here, we are kind of fearful of negative exponents. Do you realize that a negative exponent simply means that on the bottom?
Yeah, I know that.
So like if I have cows to the -2, isn't that the same thing as saying 1 over cows squared?
Yeah.
Or if I have 10 to the -1, what 10 to the -1 really is really 1 over 10 to the 1, or 1/10. Right? Now, we've taken care of our units. We've taken care of our exponents. Can someone do the math now for me on this problem?
1,687.5384.
Woo! That's a lot of numbers. Real quick on this one. Yes, ma'am?
So my calculator didn't get the last three numbers. It only rounded it to 4.
Where?
Like it got 1,697.54.
Okay. So what you're noticing right there is your calculators will sometimes auto cut off things. So you got to be a little bit careful and don't trust your calculator for your correct significant figures. But fortunately in this case, how many significant figures should I have in my answer?
2.
2. So it doesn't really matter if we cut off at
No.
4 or whatever. And by the way, I was deliberately using the exact same problem because didn't we have to use 2 significant figures when we were multiplying? And since multiplication and division are the same type of problem, mustn't we also use the 2 significant figures in our answer? So once again, I'm going to go to right here and write the cutoff. But 2 things we should know. 1, don't we already have an exponent? A. And B, isn't the decimal to the right of the line of death? In both of those situations, the only way to rectify is to do what with that decimal place? Move it all the way over to make it into good form, right? So I'm going to shift this over 1, 2, 3 places to the left. Lefty what? Largy. So now be careful because you have to view exponents as if they're in a number line. So if I have -1 and I want to get 3 larger, wouldn't I go 0, 1, 2? So now I'm going to be times 10 to the second cows to the -2. That just makes me so happy. And over here, wouldn't that become 1.69754? What does 9 get to say?
It's going to be 7.
Round up. So wouldn't that now give me 1.7 times 10 to the second cows to the -2?
We don't need to cancel off the new one, right? Just leave it there. The cows.
You can't. Those are our units.
Okay.
Those are our units. Now, are you with me so far?
Yes, sir.
There's more?
Let me just show you one wrinkle. And by the way, I'm hoping this is pretty straightforward. If you group multiplication and division together, you do the same exact things across, except the only thing you're going to do differently is your units and exponents you're subtracting versus you're adding. Which brings us to this. Let's say I had the same problem. Don't write this out. I appreciate you wanted to. But let's say instead of cows and cows, what if I had grams and milliliters?
They're the same thing.
Well, now watch. You cannot subtract a milliliter from a gram. They are not the same. That's like saying I'm going to subtract a turtle from a football.
But gram and milliliter, aren't they the same thing?
It's grams per milliliter.
So what do? Whenever we see numbers or whenever we see units, we're like, yeah, about that. I don't know what to do. We just go, well, they're being divided. So we'll write as our unit, we'll just go, well, they're being divided. You might have seen that line in some previous work. Let me remind you of some of the previous work you may have seen. Miles per hour. Ever see that one? That's an example of this. It's miles divided by hour, but miles and hour cannot be subtracted from each other. So everyone just goes, oh yeah, miles per hour. So if you ever have 2 units that are not in the same genre, you just put them both down. Yes,
If
right.
one of them has like the exponent, would it be G over like ML?
Yeah, so if for some reason, again, it's not going to happen. Let's say you had this and this, right? You go, oh yeah. And that would be that's how you'd write it. Because again, we have no way of subtracting milliliters from grams. Yes.
What about us multiplying and then
So let's try.
adding and
Glad you brought it. So let's pretend we have the same problem. Okay, same exact problem, but now we're multiplying. So boom. Again, I'm just taking care of the units right now. But if I'm multiplying, again, you cannot add a gram and a milliliter. That'd be like adding a chipmunk to a refrigerator. Ooh, that's dark. So couldn't we go grams times milliliters is my unit? That little dot in between. And that happens often with our units. We're like, they're not the same units, but we need them in our problem. Any questions? Yes, Taylor.
What if they weren't the same number?
What if they were?
Yeah. Like, would you have to?
Then you have to subtract.
Okay, would you have to convert one of them? Like,
Yeah. Oh, so I know what you're talking about. So you're. Oh, I could like hire you to do segues for me from here on out, and then maybe you could do the soundtrack. All right. So I always thought how cool that'd be if you're teaching and you just had a soundtrack in the background, like music, like crescendos when you're making your final point and students understood. And if a student asks like a question that indicates they don't understand anything, there'd be like this dark music. No, I just realized I'm recording this. So I'm just going to go back to teaching. So what you're talking about is prefixes, which is a segue into the next thing. So what if I have, let's say, centimeters and millimeters? I cannot work with centimeters and millimeters, but I can make them into the same unit. And that's where, once we know how to work with prefixes, which is the next thing that we're going to do, in fact, it'll happen in the next class, I'm actually going to put on, you have in your textbook a table of prefixes, but I'm also going to put online a table of prefixes if you wouldn't mind printing that and bringing that next class. So in that case right there, we'd have to do the conversion first. Any questions on this right here?
What if I'm like subtracting grams to millimeters?
If this is a subtraction problem?
Yeah.
Oh, you can't do it.
Okay.
And she just asked here, what if we're subtracting? When you're subtracting or adding, don't you have to make the units the same? Well, you can't make a gram and a milliliter into the same. So it's because that's the case, that wouldn't be a problem you'd have to do. Which brings us to the segue of what do we deal with when we're dealing with adding and subtracting? So let's do this. I want you to write all this down. And yet again, I'm going to share with you the key thing on this. Please work. Is it showing up behind me yet? I unplugged it. All right. Will you guys write these instructions down right now for adding and subtracting? And as soon as you've done that, I'm going to show you how to do an adding and subtracting problem. Please do not dally. Write these down quickly.
It's recording. Somebody say something.
Oh my gosh, I forgot it was recording.
What?
Really?
You do it. You do it.
You literally like.
No, I don't want to do it.
Why not?
Because I'm new and I can't get away with stuff yet.
I feel like you get. I feel like you get away with stuff more than we could.
It's literally recording.
Do you think he watches it back?
Hey guys, so what do y'all think? Should we overthrow the social hierarchy of this classroom?
Who's a social hierarchy?
No one back there.
Honestly, yes.
Boy.
I'm out.
You lead the social hierarchy and we don't like it.
What is the social
I don't know that.
Yeah. It's like the order
That
of
puts
who's
them at
like
the
the most.
forefront.
It's like the social.
Most.
Let him over here. What? Scraps.
What?
I'm trying to fix this.
I
trying to
thought
fix
he
this.
I thought he was.
No one ever said we don't want no one at the top, so I don't know
Well,
what
hey,
it is. Yeah.
Well, I
Maybe
don't
you
want
just want to be at the top.
That's my man.
I'll take a picture. Oh wait.
Wait.
If you're done, what you're in here, there was a code word that I gave you guys for multiplication division. I said least, right? There are two code phrases for this. So you might want to write these down. Pause where you're at. I'm just going to say this out loud. You can put them up next to where it says addition and subtraction. Here are the two rules. 1, line up decimal. 2, count columns. Count columns. So number 1 is line up decimals. Number 2 is count columns.
Wait, what is this a rule for?
This is
As for all addition and subtraction, just like we did the same thing for multiplication and division.
It's add.
Line up decimals and
Sorry, I can't see.
line up decimals and then count columns. Now, you guys have this PowerPoint online, so if you have to go back and look at it, you can, but I'm going to move forward. So this is the number we're going to use. So jot this number down, and I'm going to walk you through with it.
Please do.
Again, in this case, we have not included units, so please forgive me for that. But we are going to work through this problem as is. Okay, so watch. And it is incredibly important that if you have like a zone moment right now, you're going to lose this lecture, because the way we deal with multiplication and division doing significant figures is completely different from the way we do adding and subtracting. So watch. First things first. So we line up the decimal.
Wow.
Now, why does that become important? Because occasionally when we're shifting exponents around, doesn't that change our decimal location? So we want to line up our decimals. And then watch. Literally, this is what you have to do every addition problem. You start over here, and you go until you start hitting columns that appear in both lines. So isn't there a number in both columns here?
Yes.
And isn't in this column, isn't there a number in both?
Yes.
You go to the last column that has numbers in both, and you draw your line of death on the outside of that number. Now, it should be noted that once you've drawn your line of death, all these problems are the same. So your goal is draw the line of death, and then every problem is the same. Everything to the right-hand side of that line is going to be gone, and then we're going to have to write the number appropriately. So if I do the math on this, wouldn't I have 171 14.17? And you have a 1 right here, right? We're doing an addition problem. Now, follow this for a second. Does this 1 say anything that's going to be of consequence to us?
Nope.
No, it's going to fall away, right? Like, stay the same. So wouldn't my number then just be 14.17?
Yeah.
Now, I didn't have units or exponents in this problem. I understand that. But as you're looking at this problem, since the decimal's on the left-hand side of this line, you don't really need to put you don't have to make it into scientific notation, because isn't 14.17 a completely healthy number?
Yeah.
You don't have to put placeholder zeros in or anything, so we can leave it like this. But if you're like urged to scientific notate rising, you could shift this one place to the left. Couldn't you call it 1.417 times 10 to the first? This is perfectly fine though. So now let's tie it into a more massive problem, yeah? So we're going to do one that has units, exponents, and everything. And if you feel like you can handle this, then I'm free to let you roam on your own in the wild with these problems. I did not hear what you said, but I'm going to pretend it's like, yes, teacher, you're doing great. Okay, so.
What he asked was if we could write it down first and do it on our own, then he could.
That's a really good idea, but since I'm filming right now, I'd prefer to just like do it all the way through and then give you a chance to do it on your own. That's a great practice problem to do, a practice idea. But I don't want to have like a few minutes of dead space here on the film. We're going to do this times 10 to the 4th, and pick a unit for me here. Can be any unit.
Pancakes.
I heard dogs. So we're going to deal with dogs. Although whoever said pancakes, God bless you. As a fat man, I understand that, appreciate that. Times 4 dogs. And we're going to go dogs. And then we're going to add 21.6 times 10 to the 3rd dogs. Now, I'm being really gentle in this problem because aren't we adding? So when we add, what do we have to do to our exponents?
Well, at the front,
No. We've got to make them the same, right? And with our units, don't we have to make them the same? Now, Taylor brought up something just a little bit ago, is what if we have units that have the same base unit, we have different prefixes, and that we have to change them to the same unit. But right now, if I had like dogs and cats, we're not solving this problem because there's no way to make the units coincide with each other. Does that kind of make sense? So you're going to see a lot of problems where the units are the same at the beginning because it's really hard to switch units into each other until we learn how to manipulate prefixes. Yes, Ryan?
If there's a weird one like the grams and milliliters, is there a way to put it like how you have the division?
Not with adding.
Or you just can't do
You
it?
just can't do them.
Okay.
You cannot add a gram to a milliliter. They're just two opposite units. Good question, though. So let's watch this here. So our units are the same, aren't they? So we're just going to go dogs. Okay, now let's take a look at this. Don't we have two different exponents? And we must make them the same. Now,
The decimals.
you're absolutely right. So couldn't we move the decimal on either of these two to make the exponents the same? So I could take my 10 to the 4th and couldn't I make it 10 to the 3rd by reducing it and writing the exponent? Or could I take my 10 to the 3rd and enlarge it by moving the decimal to the left? Now, both of those are perfectly okay, and you're going to get the same correct answer. Can I get ahead, Bob, if you're with me on that? They're both equally good. However, I typically do my example just because I'm kind of OC this way. I always like to change the second thing into the first thing. That does not mean the other way around is the correct way, but if you ever want to look at one of my answer keys, you're going to see that that's how I did it. So I'm going to change this 10 to the 3rd into 10 to the 4th. So if I make my exponent up to 10 to the 4th, I've just larged my exponent. What am I have to do to my decimal? Wouldn't I have to move it to the left? So wouldn't that give me 2.16? Now, this is a little more challenging on a piece of paper to shift things over, so you might have to write it again. But if I make this 2.16, must I now shift the decimal place over and make it 2.6 so the decimals are lined up? Right? So up to right here, where I now have times 10 to the 4th, right? I've taken care of my units. I've taken care of my exponents. Now I have to deal with whatever rule I have to deal with for the actual math. And it's incredibly important you don't default to least, because what is the only time we're going to use least significant figures for? Multiplication and division. In this case, we've got to count columns. So when I start over here, and when I hit a column here, then here, then here, and right after here, I have no more columns that have both of them in there. So wouldn't my line of death go right here? So if I add this up, I'm going to end up with...
Wait. Oh, no, I have a question.
Okay.
Never mind.
Okay. So isn't my line of death right here? And my decimal isn't on this side? So I could just go like this, couldn't I? But whenever we have scientific notation or whenever we have exponents already in the problem, we want to write our answer in good form. Good form. So if we're going to do that, we may as well just shift it right from the beginning so we don't have to worry about anything. So couldn't I do this with this decimal? Can I go 1, 2, 3 places to the left? What's going to happen to my exponent? Wouldn't it go up 3, 10 to the 7th? Dogs. And when I now have 5.43440, this whole thing represents my significant figures. Now, pause for just a second when you look at this. What if I'd accidentally gone with least as my method of determining significant figures? Wouldn't I only have 3 significant figures in my answer if I was multiplying or dividing? Don't I have way more than 3 if I do it the correct way? Do you guys see the difference here? So if you make least your way of solving all significant figure problems, you will get all the multiplication problems and division problems correct, and you'll get every single one of the adding and subtracting ones incorrect. Yes?
For the final answer, why wouldn't we round the 0 up to 1?
Where?
Because
It's a
20.
5.
Oh, you're absolutely right. Incredible catch. I just wasn't paying attention. This 5, isn't it to the right-hand side of the line of death?
Yeah.
So doesn't it get a voice? So it's going to say, round up. Great catch, Jesse. So this should actually be a 1. Oh, that's awesome. I just was so busy with trying to count off, I did not pay attention to it. Was that what you were going to mention as well, Annabelle? Annabelle's like, oh, look at Izzy. Thank you as well, Annabelle. They both put their hands up almost identically to help me with that. Sorry about that. Does everyone understand this? Okay. So what we're going to do is we're going to start practicing on some of these. Now, as always is going to be the case, see on that back table to the right of Noah and to the left of most of all of you. See that back table? Not the back table, the back bench, lab bench. See there's you're pointing the right direction. Keep on going there. Yeah, see that? There's a little stack of papers there next to the gas valves. Those are the answer keys for every worksheet that I'm giving you. So I would encourage you, and particularly you can come anytime you want, and you can sit in, even if I'm teaching another class, you can sit back there and check your work. And I'm a big fan of you like checking your work and saying, oh man, I did this incorrectly, and then going back and fixing your work. That works out really well. Also, tests. So you need to have your parents sign the test, right? So here's what I want you to do. I want you to give them like a true analysis of what happened on the test. Like, don't be like, Mr. Dimitrich hates me and the test was so unfair. If it was like, I did not cover the material that I should have, or I did not spend the time that I needed to. I mean, here's the big one. If you didn't spend the time, be honest with them so they know, because I'm probably going to follow up if you're in a bad spot. I'm going to follow up with a conversation between you, your parents, and myself. So let's be really candid here on what areas you need help with so I can try and help you out. All right, so that ends this lecture. For homework, you're going to do 2 worksheets. One's called Significant Figure and Scientific Notation Worksheet 1. And another one's called Significant Figure and Scientific Notation Practice Worksheet 1. They are all online, and I want you to print out all of these by next class, but I printed out as a courtesy. I printed out both of them today. So I would suggest working in groups of 2 just as you walk your way through these, and this will be homework that's going to be due next class period. All right, I'm going to shut it off here.